My name is P. Ramadevi, lecturer in ECU. My subject is microwave communication and television, and today's topic is microwave link. So, in this session, I am going to tell about the microwave links, and it is having a block diagram and operation of each block, how it is does in our microwave link, and what is a microwave link is going to be seen in this session. So, first of all, what is a microwave link? The name link is nothing but a transmission line which is connecting the two devices. So, microwave link is also a same function as that of the transmission line. That means just like a coaxial cable or fiber optic cable, but in a different manner. Why? Because it is used for point to point microwave transmission between two repeaters. Okay, that means a microwave link which is performing the same work, same as that of the coaxial cable, fiber optics cable, but it is used for point to point microwave transmission between repeaters. The main operation of microwave link is nothing but which will receive the transmitted signal from the microwave transmitter and amplifies the signal, and then it is retransmitted. Okay, so this is the main usage of microwave link. That means it is nothing but a transmission line between the repeaters. Okay, so same as that of the transmission line. So this is an block diagram of microwave link. So first of all, we have to know about what are the uses of microwave link. It is mainly used for point to point communication. So in our communication, in our data communication and computer network subject, we are having different types of communications. That is point to point communication and point to multi point communication. So what is the use of that? Means whenever we are calling point to point, the media or the link is going to be shared with two devices only. That means the two devices can be interconnected with that link. The link is not shared with other devices which are nearer by. Okay, that is going to be calling as point to point communication. And when we are having the point to multi point communication, in that a link is going to be shared with number of devices. Okay, that is going to be calling as point to multi point. So the use of microwave link is nothing but point to point communication. It is used in the point to point communication. And the second one is, in order to connect in modern digital IP networks, we are going to be using microwave links. So in our networks, we are calling as internet. Okay, so what is an internet? Means it is an IP, that is internet protocol. By using this protocol, we are accessing the internet in our homes or in our offices or organizations. Okay, so that is going to be calling as IP. So modernly we are having the digital IP networks. So in that, for connectivity purpose, we are going to be using microwave links. And nowadays, for the transmission of TV signals, we are going to be using microwave links. And not only with the TV transmission, we are also using for the transmission of telephone calls, that is data usages, voice recordings or voice calls. Okay, and passing of images and video, etc. These are all can be done with the microwave link. And the next one is, it is mainly widely used in our connectivity in modern digital IP networks. But what is the capability? Means it is going to be used for 3 Gbps, and beyond that is also going to be used. Okay, that is the main use of microwave link. So these microwave links are used in 2G, 3G and 4G networks also. Not only with the 4G, nowadays it is having the 5G also. So in the 5G also, we are going to be using with the microwave links. Whenever we are using the satellite communications, the maximum we are going to be using microwave links for the connectivity. And the seventh one is metropolitan area networks. That is, whenever we are having networks, that is inter networkings the networks are going to be classified into three parts, that is local area network, metropolitan area network, and third one is wide area network. So based on the area covered or area covering of the network, we are going to be classified as LAN, MAN and WAN. So what is a LAN means? It is an we can say as that of the network which is going to be formed within the building, within the organization or within the company is going to be calling as LAN. So whenever we are calling as a MAN, it is covering the two or more cities, that is metropolitan cities are going to be covered. That network is going to be covering the number of cities. So that is going to be calling as metropolitan area networks. And what is a WAN means? It is a wide area network. We are going to be covering the worldwide networks. Okay, so like this we are going to be using number of networks in our daily life. So in this we are having the MAN networking, but it is also a wireless network. So whenever we are using the wireless metropolitan area networks, which is used for satellite communication, in that also where connectivity is going to be done within the microwave links only. Okay, that is the uses of microwave link. So the first one is used for point to point communication, connectivity in modern digital IP networks, and it is used for TV transmission, and it is used for transmitting telephone call, at the same time data usage, voice recording or voice calls or images, video conferences, like that all can be done with the use of microwave links. And it is mainly used for connectivity of the digital IP networks which are up to the 3 Gbps, and beyond that is also going to be used. And the microwave links are mainly used in 2G, 3G and 4G networks, and nowadays we are going to be using with the 5G networks also. So like this we are having number of uses of the microwave links, and the main important is wireless MAN network also. For connectivity of that we are also using microwave links. These are all the uses of microwave links. So initially the microwave link is performing the same function as copper wire or coaxial cable or fiber optic cable, but in a different manner. By different manner means by using the point to point microwave transmission between the repeaters. What it does means it receives the transmitted signal from the microwave transmitter and amplifies that signal, and then it is retransmitted. Okay, that is the main work of microwave link. Simply we can say that it is a transmission line between the two repeaters. Okay, that is the main uses of microwave link. So the next one is, when we are having the microwave link, what is the block diagram of microwave link? Okay, so in this the main blocks are antenna, circulator, receiver protection circuit, receiver mixer, band pass filter, IF amplifier and AGC, automatic gain control, and amplitude limiter, and transmitter mixture, and band pass filter, and high power amplifier, and microwave source. Okay, these are all main things. And not only with that, power splitters, at the same time mixer, shift oscillator and band pass filters. Number of things are there in this block diagram. Just like a communication purpose, what are the blocks are there, same as that is going to be same. Okay, so whenever we are having this, what is the use of antenna? So in this, a single antenna is going to be used, but two oppositely placed, which are placed two opposite parabolic reflectors with horn antennas, which are used for higher bandwidths. That means antennas are placed, but a single antenna only, but it is having two oppositely placed parabolic reflectors with a horn antennas, which is used for higher bandwidths. And what is the use of circulator means? It provides the same antenna can be used for both the transmission and reception. Just like a duplexer. So whenever we are having the duplexer, which will be switching on of a section, okay, so it is nothing but an circulator which will be moving in all of the directions, okay. So that all of the directions means we can transmit the signals, we can receive the signals. So the circulator is going to be providing the same antenna for both transmission and reception. Just the directions will be the different for the transmission and reception. Okay, so the next one is receiver mixture. So receiver mixture means in order to have the receiver mixture, first of all we have to know about the receiver protection circuit. So what is a receiver protection circuit means? It protects the receiver to avoid the damages from high power transmitters. That means which will protect the receiver instead of having receiving of the high power transmitting signals, it will stop that. So it will be stopping the receiver to avoid the damages. Okay, that is the receiver protection circuit. And the next one is receiver mixture. So receiver mixture means in this we are going to be using double conversion of frequency. Why it is going to be used means in order to avoid the interference and amplification of the quality of the signal. That means in order to avoid the interference from other signals, and in order to increase the quality of the signals, we are going to be having a double conversion of frequencies. Okay, in this the RF signal can be converted into IF and it is going to be amplified and it is reconvert to the IF into RF. Okay, that is the receiver mixture. So microwave links are in the order of 4 GHz to 6 GHz for transmission. Why? Because whenever we are having the satellite communication for transmission of signals, we are having them 4 GHz to 6 GHz for transmission. So for the amplification of these signals, it requires a microwave amplifiers. Okay, when we are having the application of satellite communication, we require microwave link also. But whenever we are having the amplification of this microwave frequencies, we require a microwave amplifiers that are very costly and difficult to maintain. Therefore, the RF signals which are going to be received from the antenna is down converted into the IF amplifier. I have already said that in our communication receiver systems, all of the receivers have an IF amplifiers only, not with other amplifiers. Why? Because for processing of the signals, it is very tough to have a processing of the signals which are in the range of radio frequency or above that. It is very difficult to process. So for that reasons, we have to convert into the intermediate frequency, then only it can be processed and it is given for the amplifier. Okay, so in this also that are the frequencies requiring the microwave frequency amplifiers, but they are going to be very costly and very difficult to maintain also. So for that reasons, we are going to be converting into IF signal, that is in the range of 70 megahertz, and this can be done by the using of mixture and local oscillator. Okay, and the next one is band pass filter. So what is the use of band pass filter means? It is used to allows particular band of frequencies, that is 70 megahertz frequency is going to be allowed. Other than that, it will be eliminated, it will reject that. And what is the use of band pass filter means? It is used to eliminate the harmonic distortions. Okay, next one is the IF amplifier and AGC. It is a low noise amplifier for amplification of IF signals, that is 70 megahertz. It maintains the gain within the limits with the help of automatic gain controller, that is AGC. Why? Because IF amplifier means which will amplify the signals of which in the range of IF frequencies. And what is the use of AGC means? Which will maintain the gain within the limits with the help of automatic gain control. Okay, next one is the amplitude limiter. So this stage will be avoiding any unwanted amplitude variations and noises, which will limiting that. Okay, if any having some amplitude variations which will be limited to a particular range, and it is going to be passing towards the transmitter mixture. These transmitter mixture which will be converting the IF signals into the RF signals, that is nothing but 6 gigahertz is going to be converted. From 70 megahertz to 6 gigahertz is going to be converted. These transmitted frequency is going to be passing through band pass filter to avoid the harmonics and noise. And after that, the band pass filter which will be allowing that transmitted signals only towards the power amplifier. And the power amplifier is going to be increasing the levels of the power levels of our signal, and that is going to be given for the antenna. So what is the use of high power amplifier? High power amplifier. So whenever it amplifies RF signals to a required level, it is usually a traveling wave tube. Generally, in that we are going to be using traveling wave tube. And a microwave source is nothing but which will be generating a high frequencies. It is a VHF transmitter, crystal oscillator. That means a high frequency of ranges of frequencies is going to be of signal is going to be generated. Okay, in modern systems, magnetron can be used to generate the microwave frequencies and high power signals. So in order to have a generation of signals only, we are going to be using VHF transmitter, crystal oscillator. Other than that, nowadays we are going to be using magnetron. Okay, so this is an operation of this microwave link. And not only with that, power splitter. What is the use of power splitter? Means the power from the microwave source is applied to power splitter, and it will split the power and deliver to 75% power to the transmitter mixture and the remaining 25% to the mixer stage. That is a use, that is splitting of the power. Okay, that can be done within this power splitter. And the next one is mixture, shift oscillator and band pass filter, which will be providing the high frequency signals, that is 6110 megahertz, and BPF will be, that is band pass filter, will be removing the unwanted frequencies from the output of the mixture. So like this, the operation can be done with the use of microwave link. Sometimes the microwave link can be calling as microwave repeater section. Why? Because it will be connecting the two repeaters. That's why it is going to be calling as microwave repeater section. Okay, this is the block diagram of microwave link. So shall we have a look on this? What is an antenna means? It is a two oppositely placed parabolic reflectors with the horn antennas, and that are used for higher bandwidths. And what is the use of circulator means? It is providing the same antenna, and that can be used for both the transmission and reception. And whenever we are having the receiver protection circuit, which is protecting the receiver to avoid damages from the high power transmitters. Why? Because I have told that whenever we are transmitting some signals, it is in the high power ranges, so that will be affecting the receiver section also. So for that reasons, we are going to be using receiver protection circuit. That means to avoid that any problems or error occurring across the receiver, that can be covered with our receiver protection circuit. And next is the receiver mixture. So what is the use of receiver mixture means? It is having the double conversion of frequency, and is used to avoid the interference and amplification is going to be done for the quality of the signal. For these reasons, we are going to be using RF signal can be converted into IF signal, and it is going to be amplified, and it is reconverted into our RF signals from the IF to RF. So microwave links are in the order of 4 gigahertz to 6 gigahertz for our transmission. Why? Because the microwave links are going to be used in our satellite communication. So in our satellite communication, the transmission of signals is going to be in the ranges of 4 gigahertz to 6 gigahertz. So for that reasons, we are going to be microwave links are in the order of 4 gigahertz to 6 gigahertz for our transmission. Okay, so amplification at this frequencies require microwave amplifiers. So in order to have the process, in order to amplify the signals, we require an microwave amplifiers. So whenever we are having the microwave amplifiers, they are going to be very costly and very difficult to maintain also. So for this reasons, we are going to be converting, that is RF signal, that is 6 gigahertz is going to be received from the antenna, is down converted into the IF stages, that is IF signal, that is in the ranges of 70 megahertz. So this can be done by using the mixture and the local oscillator. Okay, and the next one is band pass filter. So whenever we are having the band pass filters, it is going to be used to allows the particular band of frequencies. Particular band of frequency means it is only allows them 70 megahertz IF signals only, not with other. Okay, other than that it will be rejects that signals, and it is going to be used to eliminate the harmonic distortions. Okay, and the next one is IF amplifier and AGC. So what is the use of IF amplifier means? The name already indicates that which will be amplifying the IF ranges of frequencies. That means IF ranges of signals are going to be amplified. And what is the use of AGC means? Automatic gain control, and it is going to be used to maintain the gain within the limits. Okay, for that reasons we are going to be using automatic gain control. Okay, this is the IF amplifier and AGC use. And the next one is amplitude limiter. What is the use of amplitude limiter means? The name already indicates that amplitude limiting. So whenever we are having this stage, unwanted amplitude variations are going to be occurring and noise is going to be occurring, that will be limits. That is the main use of amplitude limiter. And the next one is transmitted mixture and BPF. So what is the use of mixture in the transmitter section means, which will be converting the IF signals into RF signals. That is IF signals means which is in the range of 70 megahertz, and that is going to be converting into RF signals which is in the range of 6 gigahertz. And in this transmitting frequency is passed through BPF, that is band pass filter. Why it is going to be used means, it is going to be used to avoid the harmonics and at the same time noise. Okay, this is the amplitude limiter and transmitter mixture and BPF. And the next one is high power amplifier, which is going to be used to amplify RF signal to a required levels. The high power amplifier means the name already indicates that high power amplifier, which will be amplifying the RF signals to a required levels, and it is usually using a TWT, that is traveling wave tube. And the next one is microwave source, which is going to be used to generate a high frequencies, that is in the ranges of VHF. And when we are using this, it is having a separate oscillator we are going to be calling as VHF transmitter crystal oscillator. Okay, with a varactor multiplexer. Then it is going to be used in our application. That means which will be generating some high frequency signals, and it's in the range of VHF ranges, and for that we require a VHF transmitter crystal oscillator with the help of varactor multiplexer. So in the modern systems nowadays, we are going to be using with the magnetron for generating the microwave frequencies and high power signals. That means I have already told that in our microwave frequency ranges we are going to be using different types of oscillators and different types of amplifiers. Why? Because normal amplifiers cannot be used. Why? Because it can be used for low frequencies, not with the high frequencies. Whenever we are calling as a microwave frequencies, these are applicable at high frequencies. So high frequencies, in order to tolerate the high frequencies, normal amplifiers are not workable. Our oscillators is also going to be not workable at this frequency of signals. So for that reasons, we are going to be using magnetron. Okay, so that is the microwave source. In that we are going to be using a magnetron in our modern life, which is going to be used to generate the microwave frequencies and high power. And the next one is power splitter. So what is the use of power splitter? Means the name indicates that split, that means differentiates. So the power from the microwave source is going to be applied to the power splitter, which will splitting the power and deliver to the 75% power to the transmitter mixer, and 25% of the power is going to be given for the mixture stage. Okay, that is the use of power splitter. And the next one is mixture shift oscillator and BPF. What is the use of this? Means these systems provide the high frequency signals, and whenever it is calling as high frequency signals, that is 61110, that is 6110 megahertz. Okay, so the BPF, that is band pass filter, which is going to be used for removing the unwanted frequency from the output of the mixture. This is the use of mixture shift oscillator and BPF. Okay, shall we have a quiz? So in our television systems, the characteristic impedance of the cables used is, why I am going to be having the cables means, I have already told that a microwave link is nothing but an perform the same function as the copper wire or coaxial cable or fiber optic cable, but in a different manner. That means which is providing the point to point microwave transmission between repeaters. Okay, so that is the main concept of the microwave link. So further reasons we have to well known about the cables which are going to be used in our daily life. So in our television systems, the characteristics impedance of the cable used is going to be, the first option is 75 ohms, 150 ohms, 100 ohms, 50 ohms. So please note this question, please. So please note this question. That means in our television system, the characteristic impedance of the cable used is, the first option is 75 ohms, the second option is 150 ohms, the third option is 100 ohms, the fourth option is 50 ohms. So what is an answer? The answer is A, that is 75 ohms. So we are not going to use 75 ohms. In the previous time we can also be using the 59 ohms cable also. Okay, so that is an answer. That means in our television systems, the characteristic impedance of the cables can be used is 75 ohms. Why? Because the cables is having the impedance which can be chosen with the help of impedance only. So for that reasons it is can be seen as ohms, that is 75 ohms. The next one, what are the connectors used in pairs? To form a pairs, what are the connectors used in pairs? Used in pairs are called The first one is jack and plug. The second one is male and female connectors. The third one is both the mentioned, is A and B. The D option is none of the mentioned above. Please note this question. So, what are the connectors used in pairs are going to be calling as, the first option is jack and plug, and the second option is male and female connectors, and the third option is both of the mentioned above, and the fourth option is none of the mentioned above. So, what is an answer? C, both of the mentioned above. Why? Because the coaxial cables are going to be having as jack and plug. So when we are having the twisted pairs, we are having a two types of connectors, that is male and female connectors. It is for the example of the twisted pair is going to be RJ45 connector. Okay, so RJ45 connector is having the two types, that is going to be male connector and at the same time female connector also. So for that reasons, any connectors used in a pair are going to be calling as jack and plug, and at the same time male and female connectors. So this is an answer. The next question. The mode of propagation in a microstrip line. What is a microstrip line means? It is nothing but a microwave link only. Just by usaging of the microwave link, we are having different types, that is going to be calling as microstrip line. So the mode of propagation in a microstrip line is, the first option is quasi TEM, that is transverse electric mode. Next option is TEM, only transverse electric mode, and the third one is transverse magnetic mode, and the last option is transverse electric mode. Okay, what is an option? The mode of propagation in a microstrip line is, the first option is quasi TEM mode, the second option is TEM mode, and third option is TM mode, and the last one is TE mode. Okay, what is an answer? Please note this question. So the mode of propagation in a microstrip line is going to be, the options are quasi TEM mode, TEM mode, TM mode and TE mode. What is an answer? So that is A, that is quasi TEM mode. The exact field of the microstrip line constitutes a hybrid TE and TE wave. That means it is operating in two ways, that is transverse magnetic field, at the same time transverse electric field also. Both modes can be operated, and this is going to be calling as hybrid TE and TM wave. Okay, so that is an answer. The next question. Microstrip line can support a pure TEM wave. Is it true or false? Or microstrip supports only TM mode? Our microstrip supports only TE mode. So what is an option? That means the microstrip line is going to be supporting a pure TEM wave only. The first one option is true, and the second one is false, and third one is microstrip supports only TEM mode, and the last one is microstrip supports only TE mode. So what is your option? So please note this question. So the microstrip line can support a pure TEM wave. Is it true, false, and it can only support only TEM mode, or it can support only the TE mode? What is an answer? That is B. It is false. It will not support only pure TEM wave. It can support TM mode, it can support TE mode. Okay, all of the modes are going to be supported, not only with a TEM wave only. Okay, it is a false statement. And next question. The below one is the only microwave network element that is in a TEM line. The one below is the only microwave network element that is a TEM line. Please note this question. Okay, the one below is the only microwave network element that is a TEM line. So what is that? The first one is coaxial cable, and the second one is rectangular waveguide, and the third one is circular waveguide, and the fourth one is surface waveguide. So what is an answer? A. That is coaxial cable. The coaxial cable is only microwave network element that is used in a TEM line. Okay, this is an answer. So next quiz. The device used to get the measurement of S parameters of N port microwave network is. The device which is going to be used to get the measurement of S parameters of N port microwave network is it a CRO, or network analyzer, or circulator, or attenuator? So what is an answer? That means a device which is going to be used to get the measurement of S parameters of N port microwave network is CRO, or network analyzer. The third one is circulator, and fourth one is attenuator. So what is your answer? Please note this question. The device used to get the measurement of S parameters of N port microwave network is, whether it is CRO or network analyzer, third one is circulator, and the fourth one is attenuator. So what is the answer? That is B. That is network analyzer. The network analyzer is a device used to get the measurement of S parameters of N port microwave network is with the network analyzer. Okay, this is an answer. So the next one. Microwave resonators can be constructed from open section of waveguides. That means a microwave resonators can be constructed from the open section of the waveguides. Is it true or false? Please note this question. So the microwave resonators can be constructed from open section of waveguides. It is true or false? It is false statement. By using the microwave resonators, it cannot be constructing from the open section of the waveguides. It is not going to be constructed. That is the false statement. The next one. A dielectric material in the form of a small cube or disc can be used as a resonator. That means a dielectric material is nothing but whenever we are forming a capacitor with the two electrodes which are going to be placed in between that we are going to be placing dielectric material. Okay, so it is forming as a capacitor. Like that only, a dielectric material in the form of small cube or a disc can be used as a resonator. Is it true or false? Please note this question. Okay, so when we are using the dielectric material in the form of a small cube or disc can be used as a resonator, whether it is a true statement or it is a false. So let us have an answer. That is a true. That means a dielectric in the form of small cube or disc can be used as a resonator. Is it true statement? Okay, so this is an answer. Thank you. Okay, so in this session I have told about the uses of microwave link. At the same time we are having the block diagram of microwave link. Okay, so what is a microwave link means? It is nothing but an performing the same function as an copper wire or a coaxial cable or a fiber optic cable, but in a different manner by that is nothing but an by using the point to point microwave transmission between the repeaters. Okay, so microwave link is going to be it receives the transmitted signals from the microwave transmitter and amplify that signals, and then it is going to be retransmitted. That means same as that of the radar system only, but it is acting as a transmission line between two repeaters. So whenever we are having the microwave link which will be receiving the transmitter signal from the microwave transmitters, and it is going to be amplified that particular signals, and it is going to be retransmitted. That is the microwave link. So the microwave links, what are the uses means? It is going to be used for point to point communication, and it is used in modern digital IP networks, and it is going to be used for television transmission, and it is used for transmitting telephone calls, data usages, voice recorders, voice calls, images and video conferences. Like that it is going to be used as a link. Okay, and it is mainly used for connectivity in modern digital IP networks, that is the capable of 3 Gbps and beyond that it is going to be used. And these microwave links are mainly used in our 2G, 3G and 4G networks, and in our modern life it is not only used with the 4G, it is also used with our 5G networks also. And the last one is the last of the microwave link uses, that is wireless MAN. So I have already told that we are having number of networks, that is local area network, metropolitan area network, and wide area network. So in that we are using the MAN networks. In that also we are having Wi-Fi wireless metropolitan area networks. For that also we are going to be using uses of microwave links. That means for you have to say that whenever we are using the satellite communications, all of that situations, whenever we require a transmission line, in that we are going to be using microwave link. So all of the applications of satellite communication is same as that of the microwave applications also. Okay, so that is the main usage of this microwave links. So in this session I have covered with the uses of microwave links and what is a microwave link, and block diagram of the microwave link, and I have explained the each block of the microwave link, and I have done some quiz also on the previous topic, that is on the cables. Okay, thank you so much.